Hello guys, and welcome to the next tutorial for Hive. In today's tutorial we're simply going to be recapping on what we did last time and hopefully elaborating further. So you'll see here that I've actually done quite a lot since, hopefully since the last video. And unfortunately I've already recorded this, so it makes it very difficult to re-record without feeling incredibly depressed. So what's best is that if I actually just undo it all and then redo it. Hopefully relatively quickly. I'm not sure how quickly that will take. Okay, so here we have ourselves a node, a worker, and then two other workers. These workers are actually just variables, and they just output their values, which you can specify. So if we go forward, we connect them, and we specify an output, which could print it, and we want to give these directions, and another direction. So these go in to this worker, and these go out to this worker. And this worker just prints the data for what we care. And this is an add function. So what do we need to know? Well, in Hive, aside from having just connections, there is also the push and pull connections. And we did briefly touch on this, I believe, before. But after recording a video twice, you can never remember quite the facts. But essentially, the point is this. If you have a push data, it means that the worker on the left, or rather the worker outputting the data, pushes the data into the connected worker. This means that it'll cause the worker to receive this data and do whatever it needs to do with the data. Likewise, if we have pull data, the worker on the right, which is connected by the input, will pull the data along the antenna to its own its own worker, its own self. And that's important because we can do quite a lot with it. Interestingly to note, whilst we specify antennas with push or pull, we also have to make sure that the connections are both push and both pull. So the output of one has to be the same as the input of the other in terms of push or pull. We also have to statically type within Hive. For the programmers about this, that means we have to define the type of data that is going along the wire. If we would call it isn't actually a wire, but for the GUI terms, we have to specify the data that is sent and received by two workers. It has to be the same and it has to be usable. So if we carry on forward in my edit diagram, you see I've added a blue box, a blue wire with W and a wire. Now what does this do? Well, crudely, in Hive, if we have pull data is unlike push data, which is like an RPC where it invokes a function as soon as it's pushed by the other worker. Pull data has to be started. It has to be told to be pulled. And the way we do that is with a trigger. Now, a trigger simply is a method or a function we can use when any pin is received an input. It will pull. It'll trigger a function, which in this case we can cause to trigger a pull. So what we do, the W key trigger is connected to our worker. And I'll just change my colour scheme, see if that helps me at all. Well, that didn't do good things. Knuckle docs. Yes. Oh bother, where did I go? Some of my older diagrams, you see. And this can then pull and push data. So you'll see now that these have blue dots indicating that they are push and pull. So let's make a complex example. Let's make vectors to add together. v1 plus v2 equals v3. Now the issue with this is that we don't really want to handle vector addition in one worker for two reasons. Firstly, we might want to do it inside other nodes in the node tree without actually copying an add worker each time. Say we add full vectors, we don't have to call two add nodes. Instead, we could have one big multiple adder. So we wouldn't want to use a worker. We'd want to use a drone. It's important to remember that drones work with workers. So here we have my function vadd. If we try and access this function which is within a drone class directly, you'll see it bounces off in my diagram. And this is because we can't, without doing anything extra, we cannot just access the functions of a drone. Firstly, we don't even know where the drone exists, and secondly, it doesn't exist in the concept of runtime. So what we have to do is we have to get it outside of our drone. And to get this function outside of our drone, we have to use something called a plugin. And this plugin basically takes our name of the function, which we can specify differently to what it actually is, and then it gives a reference to the function in question. And this is really good. We now have a function which can be accessed by other workers and other drones. The problem is, how do we then use this? This is where the socket comes in. Socket accesses a plugin with the same name that is given as an argument. As well as this, it then calls a function when it gets that plugin, and it calls a function which it passes the parameter value of the value of plugin. So if I have self.out, you'll see that it can interface with plugin, and the data it receives can be sent to a function. And this function I'll give you an example of as out brackets f. And out brackets f will set the self.add as f. And that means that when we call self.add, it will now be the function specified in the plugin, which is vadd. And you'll see we now have a reference directly from this worker to this plugin, to this drone method, without having to connect directly. This sort of maintains an underwater approach. We could also have something called parameters. And parameters are basically like variables for each worker. If we specify a parameter, we can access it within the worker and do stuff to it. And if we choose, we can have a parameter visible in the graphical user interface. By default they aren't unless you explicitly tell them to be visible. This is all for this particular example here. Then we started looking at the code in question. So we have a place method. Now, I don't want to explain too much about this without making a mistake, but essentially the place method is a bit like instantiation, but we don't just instantiate classes, because the problem is that we get issues with mutable types, where basically things like dictionaries, which aren't copies, they are references typically, two different workers could share the same data by accident, which would be bad. So we have special ways around this. See, we have here, we have imp equals antenna, and vimp equals variable. It's important to note this, because if I can find my diagram, which I don't know if I've still got, I don't believe I do, but essentially, Hive uses the locals dictionary to name its graphical user interface variables. So if we have a node, which is not straight for some reason, this is actually a worker, we shouldn't call it nodes. Hold on, let's just do it straight. There you go. Okay, and then we have, in this code, we have v_inp equals antenna. That would take this from the Python dictionary, and it would create an input called, wait for it, actually I was going to do artistic, v_inp. Meaning that you don't have to give it a name, you just take the name from here, which is very useful. And the same goes for all variables and antennas. So if we look at the code again, see it also specifies the type of function it does, and the data it sends and receives. Sorry, the data it receives in case of the antenna. Likewise, we have the same for the output somewhere, hopefully down here. Now, by default, creating an output doesn't actually do anything. It just specifies if we have an output pin. We actually need to connect an output to a variable. So we connect output to voutp. And this basically means that we can modify this voutp, and it will in turn modify the data we're outputting. Now, essentially, what we need to do is then determine how we call. We have a function called doAdd, but when do we call doAdd? By default, doAdd doesn't do anything unless we tell it to. Here you see we've written trigger vimp doAdd. This means that whenever vimp is triggered, it then simply, or rather, whenever vimp changes, but don't hold me to that. I think it's when it's triggered, basically. Whenever this value is changed, imp receives something, we call doAdd function. So doAdd then reads the value of our input variable and does something with it. It then sets the output to this value. And you'll see that the output is actually a variable which then maps to the output pin. So you can see we can use the trigger for more than just inputs and calling functions. We can do so much more with it. We could use it to start a timer, to stop a timer. And this is all for today's lesson, this basic introduction, but hopefully as I become more proficient with the system, we can all sort of look at more complex tasks. So thank you for watching, I hope you guys enjoy.